Okay, so here is our test review warm-up. Try numbers 1, 2, and 3 before you watch the solutions. So for number 1, this is a definite integral, and I'm going to use the calculator to find it. And we actually have 3 different calculator methods, so I will show you all 3. The first one is in Desmos graphing. I'm going to type INT for integral. Put in my lower bound, my upper bound, my function, and it tells me negative 40.5. Now in the calculator, in y equals, I'm going to type what we're taking the integral of, just this function. And then depending on what software you have, I'll show you both ways. This is the older software. I'm going to do math. Choice 9 is integral. I'm going to go to vars, y vars, function y1, comma x, comma lower bound, comma upper bound, negative 40.5. And now if you have the newer type of calculator, you're going to go to math. Well, first off, put your function in y1, math, choice 9. Nope. Oh no. Now I got to re-enter my function. You have to make sure you're on the main calculate screen when you do that y1. All right, quit. Now I go math 9. Put my lower bound, my upper bound. In the box, I go to y1. And then it's of x. Enter. Same answer, negative 40.5. So for number 2, with total area, I need to find out where this graph intersects the x-axis. So in Desmos, I can click, and I see that's at negative 1 and 6. Wow. So what that means is, since I want total area, any part below the x-axis, I need positive. So this says start at negative 3, which is here. So I'm going to do an integral from negative 3 to negative 1 of my function. But then this part from negative 1 to 6, we need to take the absolute value of, since it's below the x-axis, and we need it to be positive for total area. Total area means all positive. So what I can do is copy this, which is nice, and I'm going to change this to be negative 3 to negative 1, and then negative 1 to 6. Whoop. We get 16.6 repeating plus positive 57.16 repeating, because the absolute value of that negative is now positive. So let's add them together. And there's our 73.76. Now on the TI calculator, it's a little more involved to get those x-intercepts. In Y2, I put a second function of 0. Then I'm going to graph. And now this is in color. If you have the older kind that's all gray and black, you won't see the line on the x-axis, but it's there. So now when we go to second, trace, I'm going to go to intersect. move my cursor to around that x-intercept, hit enter 3 times, and there it shows me intersection, -1. Repeat that again. I hit the down arrow, now I'm on Y2, so it gives me a shorter path to get to this x-intercept. Hit enter 3 times, and there's 6. So that's the x-intercepts of -1 and 6, where our area, we have to break up our integrals to find total area. Oops. Then I'm going to bring back up this, make it -3 to -1. If I hit second enter, now I can change my integral numbers again, make this 6, -1, and we get both values. If for the last time you're in the classic print, you have the older type of software. You have that first one. Then I'm going to go change this to -1 to 6. So for why are they different? Did you say number 1 is a net area? Explain that a little more. It's negative because more of the area is underneath the x-axis than what's above. So the definite integral is a negative result. Number 2 is a total area. So in number 1, the section below the x-axis is negative, whereas in number 2, I made it positive to find total area. All right, number 4, we want the left and right-hand sums of the integral from 0 to 10 using 5 rectangles when n is 5. So pause the video and try that. Okay, so what you should have written for your left-hand sum, we start on the left. We're going to add up these 5 values. And since we have the lower bound of 0 and the upper bound of 10 with an n of 5, I need this 2 to multiply in front of my sum. So the left-hand sum is 114. The right-hand sum, you start at the right-hand side of your table. Add up those y values, you get 102. You cannot average these. I cannot average these because the left-hand and right-hand sum, I can't average the left and right-hand sum because the function's not monotonic. It's not always increasing or always decreasing. This is decreasing, but then it goes back up to increasing. So we cannot average them to find the definite integral. Okay, so here's another warm-up. It is, I think just these 2 problems. Nope, 2 problems here, and then I'll scroll down for a third. So pause the video, try these 2. Okay, for number 1, total area, again, I need to figure out my x-intercepts. We've got x squared minus 16. Now you could not do that. Make your algebra teacher really proud and factor. And I see we have x-intercepts at -4 and 4. So actually, since this total area is under the x-axis, the -4 and 4 are those x-intercepts. If I find the integral from -4 to 4, and find the absolute value, we'll get our answer. So we have to take the absolute value of that, which is 85.3 repeating. One other nice thing about Desmos, I forgot to point out before, you can change this number to a fraction. If you click this dot over here, it converts your answer to a fraction. All right, for number 2, arrange your integrals from smallest to biggest. So smallest would be the one with more area under the x-axis. That would be C. This portion's a bigger area than this portion. So C is smallest. A looks like they're equal. So that would be around 0. And then B, all of the area is above the x-axis. So that's the biggest. All right, for 3 and 4, use the graphs below to find the integral from -1 to 4. So I have to count up those blocks. Sorry, I should have said pause and try these 2 problems now. All right, so we have to count up these blocks. And since it's a definite integral, any area above the x-axis and below the x-axis that are the same are going to be a net area of 0. So those I'm not going to count. They cancel each other out. And then my area here, this is a base of 1, a height of 2. So that triangle is 1/2 base times height. And then this triangle is 2 by 2. So that's 1/2 base times height. We get an area of 3. So the integral from -1 to 4 is 3. Now total area, I have to count this part as positive. So first, let's figure out our pieces. The first oh, that's a height of 2. And I've got a rectangle. And I've got another triangle. And then this triangle, I'm going to still count as positive. So let's see, that's 1 plus 4 plus 1 plus 1/2. We get 6.5. Okay. Let's get to the actual review. Estimate the integral from 0 to 4. So we got 0 to 4. Let me count up my blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9, and these together make 10. And I notice each scale is 1, so I don't have to take into account the scale. Now this graph, we want to go from 0 to 4. But notice this y scale is by 2. So I'm going to double however many blocks I count. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to call this a half. And I think these make 12. So let's go with 12.5. So that is an area of 25. All right, so this problem says find the integral by averaging. It tells you to take the average. So first I'm going to find the left-hand sum and the right-hand sum. So 0 to 5, that's cut off there. When n is 5 means my rectangles will all have a base of 1. And then left, we start on the left. So 36 plus 30 plus 23 plus 15 plus 6. And the right, I start on the right, but remember you only use 5 of the numbers, so I stop there. So that's 30 plus 23, whoops, plus 15 plus 6 plus 0. Now I need my calculator. I'm trying to type instead of, I should just use the clicker. And I actually really don't need those parentheses, but now I'm going to hit second enter, and instead of 36 in the front, we added a 0 on the end, so I don't have to really add anything. We get 110, 74, and then the average. Add my numbers up. Divide by 2. We get 87. All right, for 0 to 10 now, notice our table has values that jump by 2. And again, since we're going from 0 to 10, but only want 5 rectangles, each rectangle will have a base of 2. So we need to multiply by that. And then notice as we add these up, so here's my left-hand sum, these tables are monotonic. And we got the right-hand sum. Let's see what we get. And in the right-hand sum, there is no 2. So I'm going to replace that with the 8 that I added instead. This one is 50.6. This one is 62.6. $56.6. All right, draw the right and left-hand sums from 0 to 4 using 4 rectangles. So that means each rectangle will have a base of 1. And I have to stop at 4. I like to give myself that stopping value to make sure I don't go over here. Right-hand sum means my right-hand corner. So I start on the right side of my interval is on the graph for the height of the rectangle. Here. And one more there. Left-hand sum means I start on the left. Ooh, that's super tiny. And the left-hand corner of my rectangle is on the graph. So this is extra. Use a geometric formula to find the values of the integral. So we got to figure out what shape it makes. I'll switch to Desmos for this one. We've got x plus 1. Whoop. Having typing problems. And we want to go from 1. Oh, it won't let me click there. Okay, so I'm going to go to settings, go to my table. At 1, the y value is 2. Oh, now it'll let me click there. And at 4, the y value is 5. So that's going to make a trapezoid. If I sketch that, oops, and a line going like this. And so from 1 to 4, this was a trapezoid. This is a height of 2. This is a length of 5. So a trapezoid, that formula is 1/2 the height. So from 1 to 4 is 3. And add the bases. So that is 21/2. All right, let's graph B. Oh, we got a semicircle. But we only went from 0 to 2. So that's here. So that's really a quarter of a circle. And the radius of this circle was 2. So that's 1/4 pi r squared. So that's pi. Now for C, it's going to be a semicircle again with a radius of 4. And now we went from -4 to 4. So that's the whole half circle. So half pi r squared is 8 pi. Now let's check out D. Let's see, where'd it go? Okay. That's all the way up here. And our intervals are from 2 to 5. So check this out. I can go x equals 2, x equals 5. Isn't that nice on Desmos? I love Desmos. Sorry, TI calculator doesn't do that. I can't graph a vertical line on the TI calculator. But so this shows me, actually, I want to draw on it. One more try with that y-axis. That I have a quarter circle on top of a rectangle. Let me highlight it because it's kind of hard to see with all that stuff there. Here's the quarter circle. And here's the rectangle. So we've got a quarter pi. And this radius is from 2 to 5. So that's 3. Plus the rectangle is a base of 3 and a height of 4. Uh-oh, something's wrong with my radius here. Covered up too much. Oh, here's my problem. Okay, the height of my rectangle is wrong. Okay, whoop, rewind there for a minute. Oh, holy cow. This rectangle, this circle cuts my rectangle down here at 3. I was up way too high. So let's fix that. This is a height of 3. So this is really a square. And now that makes more sense. My radius here is 3 and here, okay, so now we're in better shape. Sorry about that. So this is going to be 9/4 pi plus 9. Okay, without computing the integrals, decide if A is monotonic or not, and B, if the integral is positive or negative. Okay, so let's look at the graph. I've got x squared, and I'm only looking at x squared from 0 to 5. So yes, that is monotonic. It is always increasing. And all of this area is above the x-axis, so that will be positive. As much as I love Desmos, there's no way for me to get that to stay on top of my other screen. So this calculator at least is a stay on top portion. Okay, so this one is 0 to 5. And it's not monotonic because we decrease and then increase. So not monotonic. I spelling that right? There we go. And it's still going to be positive. It's still a positive integral because all of this area is above the x-axis. All right, so now this integral is 0 to 3. So we are monotonic, but a bigger portion is now under the x-axis. This is 0 to 2, and then there's just a sliver here. So this one will be a negative integral because more of the area is below the x-axis. All right, and lastly, well, I'm going to zoom in a little. I'm going to do zoom 4. All right. So from -3 to 3, that's not monotonic. We increase and decrease. And the area would be positive since it's all above the x-axis. All right, number 9. The velocity is given by this function, right indefinite integral for the distance the car travels in the first 5 seconds. So first 5 seconds is 0 to 5 of this function dt, since our variables are t's. B, sketch a graph. I did not set these axes up very well. Let's fix that. And 0 to 5, so it starts here, and that was the x-intercept. 5 is over here, and then it says sketch the graph of the velocity and represent the distance as area. So I have to color in the area between 0 to 5. Can I go make that connect to my parabola? So here is the visual area of distance. Find it, sure. Math, choice 9, y1, x, 0, 5, 66.6 repeating feet. If you have the newer math print, you set your integral to look up like this. You don't have to worry about those commas. Hey, use the calculator, sure. If you don't have a keyboard to type int, you can go over here to functions, miscellaneous. Here's the integral. 0 to 5 of x squared, no, dx. Then I'm going to copy and paste that, Control C, Control V, and change the function. What else we got? 0 to 3. E to the negative, and I'm just going to use x, because I already have dx. And check that out. I got all 4 of my answers. Copy and paste. Fill in the blank. Let's see. This one was 41.6 repeating. That's a crazy irrational number that you cannot change to a fraction. All right, now 14, similar to the warm-up. And look at that, I got my graph here. Find the area between the x-axis and x equals 6. So that is asking for total area. So for part A, looks like our x-intercepts are 0 to 2 of our function. And then I think this is right at 6. How helpful. But this portion I have to take the absolute value of because it's below the x-axis. All right, so let's calculate that. If you need help finding the x-intercepts, again, go back to the warm-up and rewatch how I did all the x-intercepts for all the different types of calculators. No, I forgot my dx. And while I'm at it, I see the next one says find that definite integral, so might as well type that in. I think I want fractions. That looks nice. Where's my screenshot? All right. So for part A, I've got 10 thirds plus 64 thirds equals 74 thirds. For part B, the integral was negative 18. Why are your answers different? Part A is a total area and part B is a net area. All right, here's some more review. Use the trapezoid rule. All right, so first we have to find height. End minus beginning divided by the number of trapezoids, that's 1. Now remember the trapezoid rule, all of these middle values are doubled. So I'm going to hold the spot there for that. Get my calculator. And I need the table. I want the y values specifically at 0, 1, 2, 3, and 4. So my calculator is already set to ask. If I go to second window, my independent is on ask. Since this is by the integers, if it's on auto, it's not bad, but I'm going to leave it on ask so that I can delete these. Somehow delete these. There we go, delete. And I type 0, 1, 2, 3, 4, and it gives me the y values. And then we'd have to add them up. $54. Make sure I typed that right. I did. Okay. So now if you're in Desmos, the table of values comes from this little gear up here. We got 3x squared plus x minus 5. And I hit the gear, go to my table, and then I can type in, I want to go from 0 to 1 to 2 to 3 to 4. I can get rid of all these extra ones if I come back. There we go. can get rid of the extra ones if I want. It doesn't really matter. You're just looking at these y values to plug them into your trapezoid rule to add them up. Given this function, find the y values. Let's go back to auto. There we go. So 2 is 0. 3 is 1. 1.4. 1, 4. 1.732 and 2. And sketch the area between 2 and 6. All right. 2, 0, 3, 1, 4, 1.4, 1.7, 2. Now, before I draw all over that, I need this graph a few more times. I'm going to copy and paste. Sorry, you have to draw it again. So sketch the area. I'm going to color it in. Done. All right. Let's find a left-hand sum. Let me get that table. Whoa. Copy this over too. Okay, so first I'm going to illustrate the left-hand sum. I'm going to draw my left-hand rectangles. So I start on the left. There's no height here. Go up and over, up and over, up and down. And there's our rectangles. I want to color them in. This is going to be an underestimate. So our left-hand sum starts with the height at 0. I know you might not like it because the table's vertical. I'm going to add them up. And we get 4.146. And guess what? We're going to do it again for the right-hand sum. So for the right-hand sum, I need to start my rectangles on the right. Wow, it is really hard to draw a straight line with this tablet. There we go. And then filling in our, calculating it. Bring this down. And I change the 0 to a 2. 6.146. Okay, make sure you can do all these kinds of problems independently and by yourself confidently. Wait, that was silly. Independently does mean by yourself. Make sure you can do all these problems independently and confidently before the test.